Hello and welcome to Mr. Kniesly's class. Sorry I can't be here today, but I'm on a field trip to WJLA Studios with the news crew. Today we are going to talk about what the other classes that were here when I was here talked about, which is ecosystems in balance. If you look at the objective for the day, you'll see that it says we will be able to write cause and effect relationships for changes in the abiotic factors of our ecosystem. First off, let's rewind. We're going to talk about abiotic versus biotic factors again. So, you may remember this image from the last time you had class. Last time I had arrows pointing to certain things, green arrows pointing to biotic factors, and magenta arrows pointing to abiotic factors. What I want you to do is take 30 seconds with your lab group and name which of the factors are biotic and which are abiotic. The arrows aren't there, so you'll have to use your brains. Go ahead. Alright, so let's go over a couple of the examples. For example, you may have had this thingy here called a guppy. You would say it is biotic, exactly right. So, some things like rocks are abiotic, so on and so forth. I think you guys probably have the hang of it. If not, we'll get you caught up when I'm back. Alright, let's fast forward to the part that you can do when I'm not there. Alright, ecosystems in balance. So in any ecosystem, organisms need balance. That means they need a certain amount of things. For example, with temperature, if I were to turn the air conditioners all the way up in here and it got really cold, you would be uncomfortable. Why? Because as an organism and an ecosystem, you need a specific amount of heat in order to thrive. The same thing goes for organisms anywhere. If any one part of the system gets unbalanced, either too much or not enough, then other things are affected too. Right, before we go on, this thing here is a scale. It's used to compare weights. When you put one weight on one side, the other side rises until it's the same weight as the other. We're going to use it to talk about cause and effects. So, things getting out of balance can be thought of as a cause and effect. For example, if someone adds weight to one side of the scale, a cause, then the other side will rise, an effect. Again, adding weight to one side, cause, the other side to rise, effect. Now it's your turn. With your lab table, I want you to think of a cause and an effect for each of the following places. You have 2 minutes and 43 seconds. The places are the cafeteria, the science lab, with your homework. Try to be the group that comes up with the best cause and effect. We'll share them here in a bit. I'm going to put 2 minutes and 33 seconds on the clock, and then the time is yours. All right, you may begin. All right, let's go ahead and share a couple of our things. I'll let the substitute call on 3 different groups who think that they have the best for each of these scenarios. How about the cafeteria? Go ahead and pause it now. That way I don't have to, All right, how about the science lab? You can pause it again, it's okay. All right, and how about with your homework? Very good. So, for an example, I don't know if anyone said this one, but with your homework, starting next week, if you don't have your homework done, that's the cause. The effect is you have to stay after school and do it. Cause, effect. Don't have homework done, have to stay after school. Now, why do I say next week? Well, it used to be that my after-school program day was Wednesday, which is today. Now, in the future moving forward, I've moved it to Thursday. Why? Because I auditioned for and made it into the Baltimore Ravens marching band, which is awesome for me, but it means I need to be in Baltimore for a rehearsal Wednesday evenings. Okay? So, rehearsal Wednesday evenings. Can't be here for after school. We'll be here Thursday. All right? Awesome. So, moving on. Next thing we're going to do. In our ecosystems, freshwater ecosystems have 5 factors that we'll be measuring. You will each be assigned one of these factors based on where you're sitting in the room, where you'll read it as a group and make cause and effect relationships for them. But I want to go over what they are first because it's a little tricky. Okay. First off is temperature. Temperature should be pretty easy to think about. There's a couple things that might be tricky. With water temperature, if you have a tree covering it or really deep water, it's going to be harder for the sun to heat up the water. It means the water will be cooler. Animals tend to like cooler water better than hot water. Cooler water, more animals, healthier animals. Hot water, fewer animals, not as healthy animals. Hot water can happen because factories are dumping hot water into the oceans or rivers and streams, or it can happen because it's shallow water, there has been a lot of rain, or it can happen if we cut down trees and the sun hits the water more easily. Dissolved oxygen. So, just like you dissolve sugar in a cup of tea, oxygen gets dissolved the same way. Now raise your hand if you think a fish breathes water. You're wrong. A fish breathes oxygen, just like we do, but it gets the oxygen out of the water. So the oxygen is dissolved in the water, goes past the fish's gills, it pulls the oxygen out of the water. The more fish you have, the more oxygen they need. The fewer fish you have, the less oxygen you need. If you don't have enough oxygen, you don't have that many fish. These are some of the things you need to be thinking about when working with cause and effect. And where does the oxygen come from? Generally, if there are a lot of plants in the water, there'll be a lot of dissolved oxygen. If there aren't as many plants, not as much. Keep that in mind. Conductivity. Conductivity means it's able to carry electricity. How many of you have ever rubbed your feet on the floor or a carpet or a bleacher and then shocked someone? How many people have gotten in a line and everyone feels the shock? For that shock to happen, you need to be somewhat close together. You don't have to be touching, but the closer you are together, the more the shock is. This is the same thing with particles in water. So conductivity is how we tell how many little pieces of things are in water. If the pieces are close together, then it means that electricity can travel easily. We say that it's conductive. Electricity flows through it. If the pieces are further apart because there's fewer of them, then it's not as conductive because the charge can't travel between pieces that are too far apart. pH, which is all the way over here. pH is how acidic something is. Acidic. Raise your hand if you like Sour Patch Kids. What makes Sour Patch Kids sour is the fact that they have acid. The more acid that's in something, the lower the pH. So as acid goes up, pH goes down. Now, how many of you have ever eaten a sour apple or a Sour Patch Kid or something with vinegar and had a cut on your cheek? If you have a cut on your cheek and you eat something like that, it burns, doesn't it? Well, it's because the acid is actually burning that cut. Okay? Now, if you have very, very low pH or very acidic water, it's going to be burning the fish. Fish will die. Right? So, where does the high pH or where does the low pH come from? Where do the acids come from? Well, if you have a lot of CO2 in the atmosphere, which we create through factories, driving cars, or let's stay around by cutting down trees, not having enough trees to filter it out. Then when the rain falls down, it's going to pick up the CO2. It's going to make an acid. That acid then gets into the rivers and streams and causes damage. And nitrate levels. Nitrates are things that plants need to grow. If you have too many nitrates, you might get too much plant growth, too much algae growth. If you have too few nitrates, you might get not enough plant growth. Plants might die. Now, each of these are going to be described in more detail in your lab books. So, wait a second, don't get out your lab books yet. But if you do look at your lab books, starting on page 34 and going to page 38, each of these pages will have one of those abiotic factors and a chart for cause and effect. Your job will be to, as a group, read that section and write the cause and effect relationships. You need to make sure that you really get it because you need to be able to share this with other groups when I get back. These are our desk tables. The whiteboard is right here. The projector is right here. So if you're in this table here, on this first half, these are facing the windows, you will be reading page 34. If you're back here, page 35. The center table, if you're at the first half, you'll be reading page 36. Second half, page 37. And the last table, if you're towards the back, you'll be page 38. This section here in the middle, so 6 people here. The next couple people will be going with the group over here with page 37. And the last couple people will be going over here, the group with page 36. So boom, boom. Those are your page numbers. You are going to have about 15 minutes to read through that and start with your cause and effect. You may not get all of it, and that's okay. When I get back, I will help you through it. I'm going to leave this up for a little bit longer. For the 15 minutes, I'm going to ask the substitute, please keep an eye on the time. Once the 15 minutes are up, if you hit play on the DVD for fresh water, there is a sheet that goes along with it. What I want you guys to do is follow along with this sheet. It's talking about freshwater biomes. Watch it, fill it out, do it. Good times for all. I will see you next time. All right? Any questions, feel free to email me or call or text the teacher helpline. Remember, the teacher helpline is 1-234-Kniesly. And my email is Kniesly, or Kniesly, at fcps.edu. Thank you. I know you guys were great for the sub. No concerns. Awesome. See you next time.